Here's some more series fun. How about if you have 1 over n and then also natural log of n? So what's very interesting is if you have 1 over n, that diverges. If you have an exponent, so you could rewrite 1 over n as 1 over n to the 1. And if you add just a tiny, 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 tiny amount to the exponent, that's now a p-series. P is bigger than 1, so it converges. So in a way, this question is saying, well, what if the tiny amount you add is natural log? So if you add an extra natural log at the bottom and you multiply by n, that seems like it's going to make the bottom bigger and thus the fraction smaller, and it will converge. Well, let's see. So this is a problem that we can actually integrate. So integrate from 2 to infinity, and then it's 1 over an x times a natural log of x. And this is a good time to use u substitution. And I'm going to choose the u to be the natural log of x. The reason for that is my brain tells me the derivative of natural log of x is 1 over x. And as you can see, this problem has 1 over x in it, and it even has the dx, so that means that the u substitution is going to work out perfect. Let me just erase this purple. I actually don't even have to adjust the du at all. It's just a straightforward do the u substitution. So the natural log is in the denominator, so I need to keep that there. So in the denominator, replace the natural log with the letter u, and then the 1 is still on top, and then the dx and the x on the bottom, that gets replaced with just the du. And I'm going to leave the limits off for a moment until I finish this and get back to my variable being x. So the antiderivative of 1 over u is the natural log of u. And of course I don't have to put the plus c because we are going to plug in numbers. And then replace the u with the natural log. So then it's the natural log of the natural log of x. So it's a natural log of a natural log. I don't know, it seems sort of funny. But anyway, that's how math is. It's just funny sometimes. So put the limits back, go from 2 to infinity, and first of all, it's going to be the natural log of infinity. And then minus the natural log of 2. So for this part right here, the natural log of infinity is infinity, so the natural log function does go up to infinity. If you watched one of the previous ones, I showed you the graph. Natural log goes like this. It doesn't go up to infinity very fast, but it does go up to infinity. So this is going to be infinity. Then it's going to be natural log of another infinity, which means that it's going to go up to infinity. And so this is going to be infinity, and then minus, and then this is some decimal number. I don't even really need to know what it is, because it is a finite number. Okay, yes, since you asked. The natural log of 2 is equal to a negative 0.367. Negative 0.367. Negative 0.367. So in other words, the natural log of 2 is only going to add a 0.367 to it, and infinity plus a 0.367 is still infinity. So I forgot to put my therefore, it diverges. It's going to do it very slowly because the natural log function does not go up to infinity very fast, but it does make it there.